Hello, class. Well, here's your video that I promised you. Oh, I've been having some technical problems getting this done, but I think I have it figured out now. I bought some new equipment recently, and you know how that goes. Always a hassle. So here we go. As promised, I have videos of sections 5.4 and 5.5, going to be in two different files. I believe I will post these, probably tomorrow. And I also, or maybe Thursday, I will also post your quiz at the same time. Now, the take-home quiz that you are going to bring back to class with you, and I'll leave directions for, again, how to do your take-home, where to pick it up, what the rules are, all that sort of stuff. That will be with an email that I send you. But the take-home quiz is not a material that I'm presenting here via video. 5.4 and 5.5 will be on our next quiz when I'm back from Arizona. So the quiz that you're going to do a take-home over the weekend, something like that, that will be material that we've gone over in class 2 days ago, or today's Tuesday, yesterday on Monday, and also tomorrow when I see you in person on Wednesday. Okay, here we go. Section 5.4. Well, the topic is adding and subtracting polynomials and graphing simple polynomials. So we're adding, subtracting, and graphing simple polynomials. Well, what in the heck is a polynomial? I don't think we've defined that before. So let's do that. But before we do that, I have to review something that we talked about, several times over the course of the last 6 weeks, but we need to do it again. First of all, we need to define what a term is. What is a term? A term is a number, a variable, or a product or quotient of numbers. It's either a number, a variable, or a product or quotient, or a product or quotient of numbers and variables, of numbers and variables, and those variables are raised to powers. A term is either a number, a variable, or a product or quotient of numbers and variables, and those variables are raised to powers. Okay, so let's look at an example. Here's one. I've got 4x cubed plus 6x squared plus 5x plus 8. All right. Now, are each of these terms, or is this one term? Well, let's see. What's our definition? It says a term is a number. Okay, well, that 8 must be a term. How about a term is also a variable or a product or quotient of numbers and variables? And now you see each of the remaining ones is a product of a number and a variable. Sure, those are terms, and of course those variables can be raised to powers. And these variables are raised to the third power, second power, and first power, right? We don't write the 1, but it's raised to the first power. So there are 4 terms in this expression. Well, what about these guys? What do we call that 4? What do we call that 6? What do we call that 5? Do you remember? Those are what we call coefficients, or sometimes we'll call them the numeric coefficients of the term. The numeric coefficients. All right. Well, next we've defined terms, but even more important to our work that we're going to do is defining like terms. And what is a like term? Well, let's see, like terms have exactly the same variables. Exactly the same variables. Raised to the same powers. Exactly the same variables raised to the same powers. So let's see if we have any like terms in this polynomial. Well, let's see. Well, here's a variable x, and it's raised to the third power. And that's what we got to look for, the same variable and the same power. How about 6x squared? Well, it's the same variable, x, but it's raised to a different power. No, these two are not like terms. In fact, each of these four terms are unlike terms. They don't have the same variables, and they're not raised, those variables are not raised to the same powers, making these four terms unlike terms. Four unlike, I unlike you, four unlike terms. That's what we got there. Okay. So, how do we add like terms? Or I should say, adding like terms. How do we do it? That was dumb. Okay, here we go. Well, let's see. Back in, was it second grade, third, we learned that we could add two numbers together. We never asked about, the rules why we're able to add those two numbers. We just knew 5 plus 6 is equal to 11. Well, today, I'm telling you that we can add terms that are like terms. And so 5x plus 6x, those are like terms. They have the same variable, x, raised to the same power, 1. And so Craig likes to say this is 5 apples plus 6 apples. How many apples do we have? We've got 11 apples. That's how we add like terms. As long as they're like terms, they can be combined. How about this example? What if we had 3x squared minus x squared plus 2x? Can we combine anything there? Well, yes, we can. We've got two terms that are like terms. This 3x squared has a variable x, and it's raised to the second power. Well, this term also has the variable x raised to the second power, which means we can combine them. It doesn't matter that this x squared term has a 3 and this x squared term has a 1 in front of it. No. That's going to define how they combine and how many we will have, but not the fact that they can be combined. So we can add these. We've got 3 apples minus 1 apple. That leaves me with 2 apples, or 2x squared plus 2x. Very good. How about another? What if I had 3xy plus 4yx? Can we add those together? Are these like terms? Well, let's see. Do they have the same variables? X and y. X and y. Yes, they do. Does it matter that they're turned around? No. We can rearrange these variables in any order we want. We typically do them alphabetically, but these are like terms because they have both the same variables, and both those variables are raised to the same powers. So we can combine them. What have we got? We've got 7 of them, and I'll just do them alphabetically. We have 7xy. All right, one more definition for you. Let's see, I'm going to skip a couple of these. You'll find them in your book, specifically the one on the degree of a term, but it really doesn't matter. It's not important to us. What I do want to talk about is the naming conventions that we have with polynomials. And it turns out polynomials get special names. Or certain ones have special names. Polynomial names. And the name is based on the number of terms. So let's look at some examples. Number of terms. If we had just one term, we would call that type of polynomial a monomial. Monomial. And how about some examples? An example would be 2x cubed, or 6, or 7y. Those are all monomials. How about if there's two terms? When we have two terms, it's known as a binomial. I bet you knew that one was coming. Binomial. And these guys have two terms. So it might be 4y cubed minus 3, or it could be x squared plus 7x. Both of those have two terms. Can't be combined into one term. Nope. Those are binomials. Finally, the one we'll use quite a bit is trinomial. Trinomials have three terms. And an example, we'll just make one up. How about x squared minus 2x minus 2? There's a polynomial with three terms. We call it a trinomial. Are these like terms? No. They have the same variable on the first two terms, but they're raised to different powers, so they can't be combined. Those are unlike terms. All right, let's move forward. Let's do something with these polynomials, and let's evaluate the polynomials. Evaluate polys. What does it mean? Well, let's see. I want to find the value of 2y cubed plus 8y minus 6 for, first of all, y equals -1, and then second, for y equals 0. All right, well, we've done this sort of thing before. All we're asking you to do is substitution. Wherever y appears in this polynomial, plug in the value of 1, or in a second problem, plug in the value of 0. Okay, so let's do it. In the first case, we have 2, and it says we have to cube y. Well, what is y? Y is -1, so I'm going to play it safe and put that y in parentheses. Why did I do that? Well, remember when we have that minus sign in front of numbers that we're raising to a power, things can get a little bit tricky. We went over a couple of those problems, and they were not simple, and you got to be careful. And we'll go over those again later today in I think the next section, or else at the end of this section. I don't recall, but we will get there. Let's finish this. Okay, so I was careful about my parentheses. I also have to add 8 times -1 minus 6. Okay, let's see. -1 cubed. That's -1 times -1 is 1 times -1 is -1. So I have 2 times -1. Some of you might remember from last lecture that when we raise a negative number to an odd power, that the answer is negative. That's a good rule. If it's raised to the 343rd power, you know the answer is negative. All right, let's see. We've got -8 times, 8 times -1, that's -8, minus 6 more. Or we have -2 minus 8 minus 6. That's a lot of negative numbers. What have we got? We've got -8, -10, -16 for an answer. All right. What about the other problem where we had y equals 0? Well, again, we substitute in 2 times 0 cubed plus 8 times 0 minus 6. Oh, it's going to be a simple one. 0 cubed is 0. That term drops out. 8 times 0 is 0. That term drops out. There's our answer, negative 6. All right. Let's move on and let's try adding polys, adding polynomials. What can I say we do? Let's just jump in and do one. I want to add 4y cubed. No, I'm not going to do this problem. I take it back. This one I had an error in, so I'm just going to jump to my second one. Add 4x cubed minus 3x squared plus 2x. Add that polynomial to 6x cubed plus 3x squared minus 3x. If you hear strange noises behind me, that's the 12-year-old dog who is snoring. She's a 7-pound dog, but she makes some pretty good noise. All right, so what do we do to add two polynomials? Well, what we do is, what I strongly suggest is that you take the second polynomial and you place it underneath the first one. And you do this carefully. You line up the like terms. So I've got a 6x cubed. I'm going to put that under the 4x cubed term. Those are like terms. Again, this is going to be addition. Then I've got plus 3x squared. Yep, there's an x squared term, so I can put it right there. 3x squared and an x term minus 3x. And now I just add up and down. I'm going to start at the left. Suggest you do the same thing. Let's see, we got 4 apples plus 6 apples. We got 10x cubed. We've got minus 3x squared plus 3x squared. It's going to be 0x squared. That term drops out. And we have plus 2x minus 3x. That makes minus 1x. And I'll just clean that up a little bit. 10x cubed minus x. There's our answer. Let's try another one. This time I want to add x squared minus 2x plus 5. I want to add that to 4x squared minus 2. Well, again, I'm going to take this polynomial, put it underneath the other one, lining up the like terms. All right, got an x squared, so, yep, it's addition. We got 4x squared minus 2. I'll just throw that here. Oh, no, I won't. That's not a like term, is it? No, it's not. Let's see, there's the like term, the plus 5. So I will put that negative 2 over here. Okay, so now I just add terms. I got x squared plus 4x squared. That makes 5x squareds. I still have my 2x. I'm adding 0 to it. Well, I still have my minus 2x. And I got minus 5, or plus 5 minus 2, or plus 3. There we go. Simple Simon. Adding polynomials. Line them up on top of one another and line up the like terms and just add straight up and down. Subtracting polynomials is similar, but I'm going to add a trick. I'm going to add, not a trick, but I'm going to say to subtract polys, we're going to change all of the signs to the opposite sign. Which means positive turns into negative, negative turns into positive. To the opposite sign. And then add, not subtract. Once we change all the signs, we're going to not subtract, we're going to add the polynomials. Okay, let's see how that works. Let's take, we'll start with this one. Let's take 7y squared minus 11y plus 8, and I want to subtract negative 3y squared plus 4y plus 6. Okay, so what did it say? We're going to take the second polynomial and we're going to change all the signs, and then we're going to add them. So we're going to line them up. Again, we're going to line them up where the like terms are, but we're going to change the sign when we do this. So we're turning it into an addition problem. And what have we got? We've got negative 3y squared, so that becomes 3y squared. We have plus 4y, that becomes minus 4y. And we have plus 6, that becomes minus 6. Now, because we changed the signs, we're no longer subtracting, we're adding. Let's see, that makes 10y squared. What if we wouldn't have changed the signs and added? What if we just subtract them? You know, you can do that, and some of you may prefer it, but I suggest you do this. You're going to make less errors. I've seen it 100 times. Well, let's see. We would have had 7y squared minus a negative 3y squared. Well, that's not so tough, is it? We know we can whack, change the signs, but you know, it's I prefer this way. Okay, we're adding. We have negative 11y. We're adding negative 4y. That makes negative 15y. And finally, we have plus 8, and we're adding negative 6. That gives us a plus 2. 10y squared minus 15y plus 2. Good. Let's do another. Where's a tricky one? None of them are tricky, but let's do this one. Oh, this one's a little tricky. Whoopsie. Let's take 4a plus 2ab minus b, and I want to subtract 3a minus ab plus b. Once again, that was an a there. Getting uglier instead of better. I am going to take the second one. I'm going to change the signs on each of the terms, and I'm going to move it underneath the second one and turn it into an addition problem. I also have to line up my terms, don't I? Line up like terms. So we got a positive 3a, that becomes a negative 3a. We've got a minus ab, that becomes a plus ab. And we have a plus b, that becomes a minus b. Okay, let's see, we're ready to add. We've got 4a minus 3a, or 4a plus a negative 3a. That leaves me just 1a. I've got 2ab plus another ab. That gives me 3 ab's. And we've got negative b minus b. Ah, the b's disappear, don't they? No, they don't, Craig. We've got negative b plus negative b. That makes negative 2b's. Or not 2b's. All right, there's our answer. Okay, let's look at one more topic here in this section 5.4. Call it a day. And what I want to do now is talk about graphing polynomials. And we're only going to do simple ones. I believe I gave you some homework problems with graphing. I don't recall if it's on the quiz, but let me tell you, it's not very tough. You already know how to graph straight lines. Graphing polynomials, which are curvy lines, is no different. So, here's a problem. Let's graph y equals 2x squared. Well, what we're going to do is the same thing that we did time and time again when we were graphing linear equations. We've got an equation with two variables, y and x. We're going to build a t-table, put in values of values of x, and solve for y. We'll have xy pairs, and then we're going to plot them. All right. Well, first, just a little bit about this function, this polynomial. When we have a squared term, we create a graph that's called a parabola. And parabolas look something like this. They come down and they have what's called a vertex at a certain point, and they head back out into space like that. I got a little uneven there, but that's okay. Some of them are upside down, and they might not have a point at the origin. They might have their origin might be at -2, -3 or something. So they might be skinny. They can look like this. There's another polynomial. Or they can do all kinds of crazy things. How about my yellow pen? Does that work? How about a real wide one? One might look like that. All right, so those are all parabolas. They have that characteristic shape where they come sloping in, make a quick change, and head back out again. Let's graph this polynomial. Let's start with a t-table. We're going to give values of x and plot and solve for y. I am going to do the points -2, -1, 0, 1, and 2. And I'm no longer just doing 2 or 3 points because these are more complex shapes. And to get an idea what the shape is, you're going to need at least 5 points. All right, so let's see. When x is -2, what's y? Well, let's see. X -2. That's going to give me y equals 2 times x squared. Boy, I better put x in parentheses. I better play it safe. There we go, -2 squared. Now I know that -2 times -2 is 4, and 4 times 2 is 8. I've got my first ordered pair. How about when x is -1? Well, when x is -1, I have -1 squared, which is 1, and 1 times 2 is 2. When x is 0, let's see, 0 squared is 0, 0 times 2 is 0. Yep, this one has a vertex at the origin. It's going to look kind of like that red one, although this red one looks kind of fat. I think this 2 tends to make these parabolas, they're called, a little bit skinnier. We're not done yet. X equals 1. We got 1 squared is 1 times 2 is 2. Now you see the symmetry building. I bet the next value is going to be 8. Let's see. When x is 2, 2 squared is 4. 4 times 2 is 8. There it is. Now we can graph it. How high up do I have to go? 8, 2, 4, 6, 8. Pretty horrible straight line. 2 and -2. All right, let's plot our points. -2, 8. So I go over -2 and then up to 8. -1, 2. -1 and up to 2. 0, 0. 1, 2. 1, 2. Yeah, this is a parabola, and parabolas are symmetric. And finally, 2, 8. 2, 8. And that unstraight line is really making this ugly. That's all right. Let's draw her in there. So this thing comes down like this. turns around at the origin, heads back out. That point has got to go. Now, oh boy. Killed my graph. Alright, let's put him over here a little further. There we go. And now let's draw that line. Oh, it's a pretty bad graph, but that, you get the idea. There's our parabola. What have we done? We've not done anything that we haven't done before. Simply made a t-table, plugged in values of x, solved for y using our new found expertise with exponents. There you have it. Okay, folks. Let's see. I guess that's all I wanted to say about this section. Again, this material's not on your quiz, on your take-home quiz that I'm going to leave you, but we will be quizzed on this material next week. I think it's 5, 4, 5, 5, 5, 6, and 5 something like that. All right. Well, I'm going to wrap this one up. I'll be back with a second video for you.